Understanding Dolby Atmos and its QC challenges. Audio plays a crucial role in creating a truly immersive experience in the world of entertainment. Be it movies, video games, music, or virtual reality, high-quality sound takes us to another dimension, making us feel like we're part of the action. Surround sound technology has been at the forefront of audio technology revolution, which has come a long way since its inception. It started with mono and stereo systems, which provided a sense of depth and directionality by using two speakers. However, a real breakthrough occurred with the advent of 5.1 surround sound system. Dolby Atmos further stands out as a game changer in the audio industry. Let us understand in detail about Dolby Atmos in this post. What is Dolby Atmos? Dolby Atmos is a revolutionary leap in surround sound technology introduced in the year 2012. It takes the audio experience to a whole new level. Unlike traditional channel-based systems like 5.1 or 7.1, which assign sounds to specific speakers, Dolby Atmos is object-based. This means that instead of being limited to channels, sound designers can now precisely position sound as individual objects in a 3D space. They can move sounds around freely, including overhead, to create a truly three-dimensional soundstage. With Dolby Atmos, each sound can be precisely located and moved independently in real time, allowing for a more natural and dynamic audio experience. Imagine a scene in a movie where a helicopter is flying overhead. With traditional surround sound, the sound will move from one speaker to another. However, in Dolby Atmos, the helicopter sound becomes an audio object that the sound designer can move smoothly and seamlessly across the entire listening area, including above and behind the audience, adding a new layer of realism to their experience. One of the key features of Dolby Atmos is the inclusion of height channels. While 5.1 systems are limited to horizontal sound placement, Dolby Atmos introduces speakers in the ceiling or upward-firing speakers that bounce sound off the ceiling. This enables the creation of sounds coming from above, further enhancing the feeling of being in the middle of the action. Dolby Atmos has undeniably revolutionized the sound experience in our entertainment industry. By liberating audio from channel-based constraints and introducing the concept of audio objects, it offers a level of immersion and realism that is truly awe-inspiring. Some of the modern applications for Dolby Atmos include movie theaters, home theaters, music productions, virtual reality, theme parks, gaming, audiobooks and podcasts. Rendering in Dolby Atmos. In Dolby Atmos, rendering refers to the process of taking audio content that has been mixed with object-based metadata and transforming it into the final audio output for playback on a specific audio system. The rendering process in Dolby Atmos involves the following key steps: audio object-based mixing. In Dolby Atmos, audio content is mixed using an object-based approach rather than traditional channel-based mixing. Instead of assigning specific sounds to fixed channels, audio objects are created, each representing a sound source, e.g. footsteps, raindrops, a passing car. These audio objects are then positioned in a virtual 3D space, specifying their exact location and movement within the sound field. Metadata embedding. Metadata is additional information attached to the audio objects that defines their positions and movements in the 3D sound space. This metadata ensures that the playback system knows precisely where and how to render each audio object to deliver an immersive audio experience. Rendering for specific speaker configuration. The Dolby Atmos rendering process takes into account the specific speaker setup and channel configuration of the playback system. Dolby Atmos supports a variety of speaker layouts, including setups with speakers placed overhead or even in a height layer, in addition to the traditional surround sound speakers. Decoding and playback. the playback system such as a Dolby Atmos-enabled AV receiver or a soundbar decodes the metadata embedded in the audio content and maps the audio objects to the appropriate speakers. This ensures that sounds are accurately positioned in the 3D space around the listener, creating a lifelike and immersive audio experience. Challenges in implementing Dolby Atmosphere. Dolby Atmos requires additional speakers, including overhead speakers or upward-firing speakers for height channels. Proper speaker placement is crucial to achieve the desired three-dimensional audio experience. For existing setups that are not Dolby Atmos enabled, upgrading to support this technology can be an investment. This may involve purchasing new AV receivers, amplifiers, or speakers capable of handling Dolby Atmos processing and rendering. While the number of movies, TV shows, and games mixed in Dolby Atmos is continually growing, not all content is available in this format. Therefore, the availability of Dolby Atmos content may initially be limited, especially for older or niche titles. However, as the technology gains popularity, more content is expected to be released in Dolby Atmos format. How can Venera help implement Dolby Atmos? We offer automated quality control and verification checks for audio content mixed in Dolby Atmos. This ensures that the content adheres to Dolby Atmos specifications and standards, minimizing errors and issues during the production process. We also have the capability to integrate with existing post-production and content creation workflows, making it easier for professionals to incorporate Dolby Atmos technology into their projects. On top of this, our Quasar product is a native cloud QC solution, allowing for collaboration and review of Dolby Atmos content across different locations, simplifying the workflow for remote teams. Some of the features of our products related to Dolby Atmos are: Quasar Pulsar supports all prominent mastering formats, be it ADM, BWF, IMF IAB, or DCP IAB track files wrapped in MXF container. If IAB immersive audio bitstream is used in IMF DCP package, Quasar Pulsar can create the virtual audio track based on CPL timeline to process the audio correctly. Dolby Atmos program level metadata is extracted and reported as part of the QC report. Quasar Pulsar can also verify the rendering outputs for any possible decoding issues. Supported rendering formats are 2.0, 5.1, 5.1.4, 7.1 and 7.1.4. Stereo 2.0 and 5.1 rendering outputs can also be verified for any possible baseband issues, be it loudness issues, peak issues, or any other baseband level violations. The complete list of supported baseband validations is as below: audio drop, mute, silence, test tone, audio loudness, loudness range LFE validation, mosquito tone, clipping, EAS tone, true stereo, phase mismatch, audio peaks, quasi peak, true peak, sample peak, language identification. Conclusion. To wrap up, the world of audio entertainment has been forever transformed by the revolutionary technology of Dolby Atmos. This immersive sound format allows audiences to experience a level of audio realism that was once unimaginable, enveloping them in a three-dimensional audio environment like never before. However, such groundbreaking advancements come with their own set of challenges. Quality control QC is of paramount importance to ensure that the magic of Dolby Atmos is delivered flawlessly to audiences worldwide. Rigorous testing, monitoring, and adherence to strict standards are necessary to maintain the highest level of audio fidelity and ensure a consistent and captivating experience for consumers. As content creators and audio professionals continue to embrace Dolby Atmos, investing in robust QC processes becomes indispensable to unlock the full potential of this extraordinary audio technology and to continue pushing the boundaries of auditory immersion. By recognizing and addressing the QC needs of Dolby Atmos, we can collectively embark on a journey towards a future where audio experiences surpass all expectations, setting new benchmarks for the art of storytelling and captivating audiences like never before. Thank you for listening to our podcast. For more details, visit our website to find extra resources.